One of the really important ideas in trigonometry is the idea of an identity. Strictly speaking, an identity in mathematics is a statement which is always true, and there are certain parameters that you need to be able to deal with. A way to think of it for our particular semester is this. Because all the functions are defined in terms of the same right triangle, and the right triangle assures us that Pythagoras is working, because all of this work is based on the foundation of Pythagoras, there really is just one idea here. It's Pythagoras. Because of that, and a few other things, the functions tend to have some interrelationships which at first blush you might not realize, but it turns out become particularly useful. So one way to think of an idea of an identity, this is not official, but this is a way to think of it. An identity is establishing a relationship that the functions have. And knowing those relationships very often afford us different tools so that if a problem is difficult trying to approach it from one method, you can use the identity to be a different tool and use that tool to approach the problem. And very often the solution comes much, much more easily, much more readily using the identities. So think of identities as relationships between the functions and tools to be able to use later on. There are some specific cases. I just finished in the summer section. I just finished teaching a Calculus 2 course. And there are some specific places in the Calculus 2 course where the only way to solve the problem is to use the identities that you learn way back here in trigonometry. They don't go away. They're very important. They're very valuable. They're very useful. And so the identities become something that really help you out if you can learn them, if you can know how they work. We're going to start our investigation to the idea of trigonometric identities, trig identities. And the first set of identities we'll talk about are called the reciprocal identities. And there's an idea we have already seen in play. What we're going to do is take that idea as a fulcrum and run a lever across that and be able to gain some advantage, see my little metaphor there, gain some advantage to be able to do some work later on here. So, this is a relationship that is true of some of the trigonometric functions. Here's an example. Sine of theta is equal to 1 over cosecant of theta. That is true for as long as these functions are defined, which is to say this denominator is not equal to 0. As long as these functions are defined, this is always true. This is always true. And there are certain problems where you have sine in the problem and it's very difficult. What you can do is take that out and in its place put in 1 over cosecant, and very often that makes the problem significantly easier. Or vice versa. You might have a problem where this is present and the problem is difficult. Take it out, in its place, put in sine theta, and then the problem becomes easier. The point is this. This is always true. This, this needs to go in your brain. This needs to be part of your mental furniture. Being able to replace sine with 1 over cosecant and vice versa is fundamentally important. Now what I'm going to do is show you why this is true. Why is this true? Let me show you why it's true. Look at that right-hand side. See the right-hand side? Take cosecant and replace it with its x, y, r definition. Luckily, you now know your x, y, r definitions. If you don't know your x, y, r definitions, you need to know them so that now we can say, luckily, you know the x, y, r definitions. They are never, ever, ever going to go away. So you might as well learn them now and save yourself a lot. Professor Norman, for me, used to say, save yourself a lot of heartburn. So learn your x, y, r definitions. Well, what is the XYR definition? It's 1 over cosecant, right? What's the cosecant definition? That is R over Y. All right? So I know this fraction is equal to that fraction because that's the definition of cosecant function. But look what we have. What is this equal to? How do you divide by fractions? So look, we have a complex fraction, right? Complex fraction. One of the reasons we teach complex fractions way back there in basic algebra is because you need to know how to handle complex fractions. And here's one, smacking you right in the face. This is a complex fraction. We know that complex fraction, this is 1 divided by R over Y. We know this is 1 divided by R over Y. But how do you divide? What does it mean to divide by a fraction? Let's kind of cut this to the chase scene. What does it mean to divide by a fraction? Remember that rule? Yeah, to divide by a fraction, you multiply by the reciprocal. That's why these are called the reciprocal identities, because they're all based upon this reciprocal relationship. Reciprocal here is Y over R. But what is 1 times I don't care? 1 times I don't care is the I don't care. But what is Y over R? What is Y over R? What is that the XY definition for? Yeah, Y over R is sine of theta. And there we have it. See, look, I have proven this to be true. This is a proof, just like your glory days back in basic geometry. I know this is equal to that, and I know A is equal to B, and B is equal to C, and C is equal to D, and D is equal to E. Therefore, A is equal to E. This, you can call this a proof, you can call this verify, but this is a proof that this statement is true. What I will do, come exam day, I will choose one or other of these identity. It turns out there are 12 of these you could pick. There are 12 identities of this variety. I will pick one of those. I'm telling you right now, I'm going to pick one of them, and I'm going to say, write the proof that this statement is correct. When I say that, I mean this. I don't mean fiddle-faddle around the side and write down a few things over here and then write a few things. No, what I mean is when I say prove this, you start with the more complicated side. You start with the more complicated side. Write that down. Start with the more complicated side. You replace and simplify, and if you do it correctly, you should generate the other side. You need to start with one side of the equation and end with the other side of the equation. All right? Let me show you what is not acceptable. You may have done this before in some other class, and I don't care. What I'm going to do right now, this is not acceptable. Not acceptable. This is not acceptable. Sine is Y over R. This is 1 over R over Y. So this is Y over R. And this is 1 times R over Y. And this is Y over R is equal to Y over R. This is not acceptable. I don't care if you find a cure for cancer. You're not getting credit out of me if this is what you write. There are problems with this logically. There are problems with this structurally. There are problems with this pedagogically. There are all sorts of problems with this that might not be obvious from your side of the camera at this stage of the game. All that said, if you do this, you're not getting full credit. I don't care what you do. If you do this, now that you know, if you do that anyway, then what you're saying is I am volunteering to lose some points. So, this is the structure. You start by writing down. You don't take this and go both sides. You write down one side. What is that equal to? What is that equal to? What is that equal to? And what is that final result? It should take you about that long for any of these. And this is a demonstration of the first of these reciprocal identities. Now, there are, as I think there are, is it 12 of them? Maybe there's just 6 of them. I guess I counted wrong. So what do we have? We have sine theta is 1 over cosecant theta. Yeah, there's only 6 of these. Cosine theta is 1 over secant theta. Tangent theta is 1 over cotangent theta. Cotangent theta is 1 over tangent theta. Secant theta is 1 over cosine of theta. And cosecant of theta is 1 over sine of theta. Those are the 6, not 12, I said earlier, 6. These are the 6 reciprocal identities. And number 1, you need to know those. You need to know those. You need to know them. They need to be in your brain, that you need to know those. All right? And you should be able to construct a proof of any one of those 6. You should be able to construct, very similar to what we did here, a proof to any one of those 6. Let's just pick one here at random. I'm going to pick cotangent. Just at random, I just pick cotangent. So I want to show that cotangent is equal to 1 over tangent. So you tell me, what have I been barking at you the whole video about? Which side do you start with? Which side do you start with? You start with the more complicated side. Write that down. Start with the more complicated side. So the more complicated side. 1 over tangent is more complicated than cotangent. So start with the more complicated side. And write what that's equal to. You know this is equal to 1 over, what's the definition of tangent? What's the XYR definition of tangent? Well, if you know your XYR definitions, that's good news, because then you know your XYR definitions. The XYR definitions is this is Y over X. But how do you divide by a fraction? Divide by a fraction is 1 times the reciprocal. And 1 times anything is just the anything. But what is X over Y? X over Y. X over Y, that's the definition. That's the XYR definition for cotangent. And we have established that 1 over tangent is equal to cotangent. You start with the more complicated. That's equal to this. That's equal to this. That's equal to this. That's equal to this. And so if A is equal to B, and B is equal to C, and C is equal to D, and D is equal to E, then what we may conclude from the logic is A, therefore, equals E, which is what we were after. So, 2 things. Know these. Don't have any doubt. You need to know those. Flashcards, that's what I would recommend. Students have done this in the past. Flashcards, whatever you need. Writing them in this order really helps because you have the reciprocal relationships. Notice that sine 1 over cosecant, cosecant 1 over sine. That's why I always write them in this sequence to reinforce the reciprocal relationships. And then we also have 1 over tangent. And then we have the proof. The other thing is know them. The other thing is be able to construct a proof of this nature for whichever one of these 6 I pick out to put on exam day. Because I'm telling you right now, there's going to be one. So you might what I would do if I were you, I'd just practice them all. Practice them all. You know it's coming, so you might as well practice all of them. So these are the reciprocal identities. Make sure you have those firmly nestled in your mind. They just need to become part of your mental furniture.